Welcome back to the deep dive. Have you ever stopped to think about the sheer, invisible complexity that makes your car safe? I mean, modern vehicles, they're basically super sophisticated computers on wheels now. And making sure they're safe isn't just, a good idea. It's this incredibly detailed, managed process. In this deep dive, which is actually part of our series looking into ISO 26262, we're going to build on what we discussed last time. In the first deep dive of this series on ISO 26262, we looked at part one, the vocabulary. So if you caught that, you've got some groundwork. Today, we're jumping into part two, management of functional safety. This part is really about the how and the who of safety. It's about the organization, the project management, how safety is actively built in, not just hoped for.
That's exactly right. Yeah, our mission here is really to pull out the key takeaways from the standard, from ISO 26262 Part 2. We want to give you a clear path to understanding how functional safety is managed in the automotive world, sort of a shortcut to the core ideas. It's about seeing how safety gets engineered from the very beginning.
Okay, perfect. So let's unpack that. When we talk about managing functional safety, what are the big picture goals? What is ISO 26262 Part 2 trying to get organizations to achieve? Well, the standard really lays out five main objectives. The first one, and you could argue it's the bedrock, is instituting and maintaining a safety culture. And that's not just, a buzzword. It means creating an environment where safety is genuinely valued, where people feel empowered to raise concerns.
This is about the mindset, the environment.
Exactly. It fosters open communication, makes sure safety isn't just one department's job, but everyone's responsibility. It's about embedding safety deep within the organization's thinking.
Okay, that makes sense. It has to start with the culture. What's the second objective, then?
The second builds on that. Instituting and maintaining adequate organization-specific rules and processes. You need structure. Clear, documented ways of doing things, how you design, how you test, how you verify. This ensures consistency. You can't rely on just one person knowing how things work. It has to be systematic.
Right. Documented procedures for repeatability. Got it. Then third, you need processes for the adequate resolution of safety anomalies. Things will go wrong, right? You'll find bugs, maybe sensor issues. So how do you systematically find them, analyze them, fix them, and make sure they stay fixed? The standard demands a proper structured approach here.
Okay, so handling issues when they pop up. What about the people involved?
Ah, yes, that's number 4. Instituting and maintaining a competence management system. This is critical. It means making sure everyone involved, engineers, managers, testers, has the right skills, the right training for their specific safety responsibilities. Especially for high-risk components, you need top competence.
So training and skills are formally managed. Makes sense. And the last one.
The fifth objective links quality and safety. It's about instituting and maintaining a quality management system that supports functional safety. Quality management, like ISO 9001, provides a good foundation, but this objective ensures those quality processes like configuration control or documentation specifically bolster the functional safety efforts. So for you, the listener, these 5 things aren't just items on a checklist. They're the pillars ensuring safety is managed systematically, from the top all the way down.
That's a really solid framework. Okay, so with those objectives as the foundation, how does the actual safety journey look for a car part or system? The standard talks about a safety lifecycle, right? Often shown as a V model.
Yeah, exactly. A journey is a good way to think about it. And yes, the V model is a common way to visualize the core development part. It all starts way before you write any code or design any hardware with the item definition. This is where you define exactly what the item is. Is it the whole adaptive cruise system? Just the radar sensor? You define its functions, how it connects to other things, the environment it works in, and any known hazards up front. It's about setting clear boundaries.
Defining the scope, precisely. Okay.
Then comes the hazard analysis and risk assessment, the HARA. This is really fundamental. Here, you systematically identify potential hazards, what could go wrong that leads to harm. You estimate the probability of being in that situation, exposure, how well the driver could potentially react to prevent harm, controllability, and how bad the harm could be, severity. Combining these gives you the automotive safety integrity level, the ASIL.
ASILs. People hear that term a lot. ASIL, A, B, C, D. What do they practically mean? How do they impact things?
Great question. They're basically risk classifications. ASIL A is the lowest risk level, ASIL D is the highest. Something safety critical, like steering or braking functions, often ends up with components at ASIL D if a failure could be catastrophic and hard to control. And the key thing is, the ASIL level dictates the required rigor for development and verification. ASIL D demands the strictest processes, maximum independence in testing, really robust measures. ACE-LA much less so. It scales the effort to the risk.
Okay, so the HACE-LA and ACE-LA determination set the stage for how carefully everything else needs to be done. What follows that?
Once you have your safety goals from the HACE-LA and their ACELs, you develop the functional safety concept. This translates those high-level safety goals into specific functional requirements. What does the system actually need to do to be safe? And you start allocating these requirements to different parts of the system architecture.
Got it. Defining the what, and then the actual building starts.
Right. Then you move into product development. And this typically follows that V model structure happening at 3 levels. There's the system level, where you define the technical safety requirements, the overall architecture, the system design. Then you test and integrate at the system level. Then you dive deeper into hardware level development, specifying hardware safety requirements, designing the circuits, and then integrating and testing the hardware. And similarly for software level development, software requirements, architecture, coding, unit testing, integration testing, the whole software V model. Each level specifies, builds, and then verifies.
System, hardware, software, each with its own V-cycle, essentially.
Pretty much, yeah. And finally, the life cycle covers production, operations, service, and decommissioning. Crucially, planning for these later stages starts way back during development. You have to think about how to manufacture the item safely, how it will be maintained in the field, how repairs are handled, and even how to safely take it out of service at the end of its life.
Wow, okay. It really hammers home that safety isn't just a design thing, it spans the entire existence of the product. Now, managing such a complex life cycle, that clearly needs structure. You mentioned roles and responsibilities. How does the standard organize the management side of things? You said there were layers?
Yes, exactly. It breaks down safety management into 3 distinct but connected layers. The first is project-dependent safety management. This is really where the day-to-day safety work happens on a specific project. It involves defining who does what, assigning safety roles. It also involves doing impact analyses.
Impact analyses. What does that cover?
Well, figuring out the safety implications if you're creating something new, modifying an existing design, or even reusing a component from somewhere else.
Okay, that reuse point sounds tricky. If you pull in, say, a sensor from an older model that wasn't designed to ISO 26262, how do you handle that in a new system that needs to meet the standard? That must come up a lot.
Oh, absolutely. It's a very common scenario. The standard has ways to deal with it. Sometimes you can use a proven in use argument, showing it has a long track record of safety in a similar context. Other times, the supplier might need to provide extra safety evidence. Or you might need to decompose the ACRL, essentially break down the safety requirements, and maybe add external monitoring or safety mechanisms around that existing component to meet the overall system's safety goal. You have to justify its use in the new context.
Right, so you assess and potentially compensate for its original design limitations. Makes sense. What else falls under project-dependent management?
It also includes tailoring the standard safety activities if needed. You might not need every single clause for a simple ACLA component, but you have to justify why. Developing the detailed safety plan for the project is key here. Coordinating everything, tracking progress, especially with suppliers, making sure all safety activities happen correctly, and crucially, building the safety case.
The safety case, that sounds important. What is that exactly?
Think of it as the master argument. It's a structured document or set of documents that lays out the claim that the item is acceptably safe and provides all the evidence to back up that claim, requirements, analyses, test results, everything. It's what you'd show to an assessor. And finally, this layer includes performing the functional safety assessment and making the formal release recommendation for production.
Okay, so that's the project-specific execution. What are the other layers?
The second layer provides the foundation. Organizational level functional safety management. This is about the company's overall capability and commitment to safety. The organization has to define its functional safety policy. It has to actively foster that safety culture we talked about, training, reporting mechanisms, preventing negligence. Roles and responsibilities across the entire organization need to be clear. Competence management is handled organizationally too, ensuring processes are in place to train and qualify people. They need documented standard safety processes that all projects can draw from. Managing interfaces with suppliers, qualifying development tools, especially for ASLB and higher, that all sits at the organizational level.
So the organization provides the playground rules, the resources, the overall safety umbrella.
Exactly. It ensures consistency and capability across all automotive projects the company undertakes.
And the third layer?
The third is project-level functional safety management. This is where the organizational rules meet the specific project needs. Here, you define how ISO 26262 will be applied to this specific project, which lifecycle phases are relevant. You develop that detailed project-specific safety plan we mentioned. You build the safety case throughout the project lifecycle, gathering evidence as you go. Change management is huge here. Every single change, no matter how small, needs its safety impact assessed.
Every single change. Wow.
Yep. You also need rigorous configuration management, keeping track of all versions of hardware, software, documentation, tools. Verification planning happens here, defining all the reviews, tests, analyses needed, managing all the work products, the HA array, the safety requirements, test plans ensuring they're created, reviewed, approved, stored correctly, and constant communication, status tracking, regular reviews. You can see how they interlock, right? The organizational level sets the stage. The project level executes within that framework, tailoring it as needed.
It's definitely a layered approach. Now, within all this, there's often one person who seems central to the functional safety manager, the FSM. What's their specific role according to Part 2?
Absolutely. The FSM role is explicitly required by the standard for each project. They are the central coordinator for safety. Their main jobs are ensuring the project actually complies with ISO 26262, developing and maintaining that project safety plan, making sure safety activities are done correctly in every phase. They're also the main point of contact for safety assessments. They support building the safety case, and they coordinate things like confirmation reviews and audits.
And isn't there a point about their independence?
Yes, a very crucial one. The standard stresses that the FSM needs to be independent from the development teams, particularly for the higher ASILs like C and D. This ensures they can make objective judgments about safety without being influenced by project pressures like cost or schedule. They're essentially the project's safety conscience.
The safety compass, guiding the project.
Yeah.
Okay, so the plans are made, the work is done, the FSM oversees it. How do you actually confirm safety has been achieved? You mentioned confirmation measures.
Right. These are independent checks to build confidence. There are 3 types. First, confirmation reviews. These are usually done internally, maybe by someone from a different team or with specific expertise. They review the safety work products, the documents, the analyses, checking for correctness and completeness. It's like a detailed peer review for safety documents.
An internal check on the paperwork, basically.
Kind of, yeah. Second is the functional safety audit. This looks less at the documents and more at the process. Auditors, who can be internal or external, check if the project team is actually following the defined safety processes laid out in the safety plan and the organizational procedures. Are they doing what they said they would do?
Checking adherence to the process rules.
Got it. And third, the highest level is the functional safety assessment. This is a formal judgment on whether functional safety has been achieved for the item. It's done by an independent assessor or team. And the required level of independence ramps up significantly with ASIL. For ASIL D, you typically need a completely separate external organization to do this assessment. They look at the safety case, the evidence, the audit results, everything to make that final call.
So multiple layers of checks with increasing independence for higher risks.
Exactly. It's all about building justified confidence in the safety of the product before it reaches the customer.
Okay, this is incredibly thorough. But underlying all these management activities and confirmation measures, there must be some basic operational processes keeping things running smoothly, right? What are these supporting processes Part 2 talks about?
Yeah, absolutely. These are the essential nuts and bolts, the operational backbone. Part 2 mentions them, and many are detailed further in Part 8 of the standard. They include things like documentation management. You need solid processes for version control, traceability, storage, and retrieval of all safety-related documents. Without that, things get chaotic fast.
Traceability seems key.
Hugely important. Then there's change management, which we touched on, rigorously evaluating the safety impact of any change. Configuration management is vital to ensuring you know exactly which version of software is running on which version of hardware with which calibration data, and keeping it all consistent. There's also tool qualification, assessing and ensuring the software tools you use for development, compilers, model generators, test tools, are suitable and reliable for safety-related work. Interface management is about managing the communication and responsibilities between different teams or between your company and suppliers. Very important in complex projects. Requirements management ensures safety requirements flow down correctly, are clear, testable, and traceable throughout the lifecycle. And finally, assessment management, which covers the planning and execution of those audits and assessments we just discussed. It raises the question, could you even do functional safety properly without these robust supporting processes? Probably not. They might seem like background tasks, but they're absolutely critical. The unsung heroes, as you said earlier.
That's a great way to put it. What a deep dive this has been into the management heart of automotive safety. We've seen ISO 26262. Part 2 isn't just rules on paper. It's really a comprehensive blueprint for building and managing safety throughout the entire life of an automotive product. It really emphasizes embedding safety from the start.
Exactly. And maybe the most interesting thought here is that part 2 really shifts safety thinking. It moves it from being just a desired characteristic of a product, something you hope you achieve, to being a managed, verifiable, and continuous process. That's a fundamental shift.
The shift from hope to process, like that. Well, stay tuned for our next deep dive. We'll be getting into ISO 26262 Part 3, focusing on the concept phase in more detail. Please share this deep dive with all the automotive enthusiasts in your life. And for more automotive tech insights and deep dives like this one, do like, share, and subscribe. Thank you for joining us.